It's 5.99 grams titanium and 4.01 grams of oxygen. Determine the empirical formula and name for this compound.
Okay, so what is the very first step outlined in finding empirical formula?
Determine the mass of the element.
Okay, so let's determine the mass of each element. What are they?
5.99 grams.
Titanium and?
4.01 grams.
So when you find them, you should have these. That is your very first step. So by reading the problem and identifying what the given information is, you have accomplished already the very first step. So here's your 5.99 grams, 4.01 grams of oxygen. Okay, very, very important. When I asked first period, find the mass of each element, they looked at the periodic table and told me that there's 16 grams of oxygen. That's not what we start with. We always start with what is given in the problem. Okay? All right, second step. What is my second step?
Convert the mass of each element to moles.
Okay, convert them to moles. I have grams. Can I go to moles directly?
No. Yeah, go 1.0.
Now, think about this. Remember, you have this circle. What's in the middle? And you got grams, liters, and like particles, right? Exactly. To go from moles to grams, what is the conversion factor we need to use?
1 mole.
Molar mass. So this would be a good time to take out your note that's got this entire thing on the front page. So go ahead and do that to make sure you know what's going on. So, I got grams, and I want to go to moles. What is the unit at the bottom that needs to be there? Grams or moles?
Grams.
Grams. So, you need grams at the bottom. What at the top? Moles at the top. 1 mole. There. 1 mole for how many grams? Where do we get that number from? Periodic table. I'm going to give it to you this time. So periodic table says that I have 47.88 grams of titanium for 1 mole. Now, you're going to multiply across, and I'm going to divide 5.99 divided by 47.88. When I do so, I get 0.125 moles of titanium. Yeah. I don't want to worry about stick figures right now, but perhaps. Okay, but you have 4.01 grams of oxygen. If you got 4.01 grams of oxygen, what is your next step again?
Gram. Molar mass.
I'm going to have to find its moles again. So number 2 says if you have found the mass of the elements, I want you to find the moles. That means you find the moles for each of them. So I'm going to go ahead and find all of them. What's the unit at the bottom? And the unit at the top is? So we're going to fill it in. And when you do the math, you get this. Okay, read the next part. What is number 3 saying? Say it louder.
Find the mole-to-mole ratio for each element by dividing the number of moles of each element by the smallest number of moles.
Good. So you have found the mole of titanium
I get 125 from that.
and mole of oxygen. So 0.125 versus 0.251. Which one is smaller? 0.125. Jacoy, do me a favor, watch this because I'm really worried that you're not going to follow me. Okay, so you got 0.125 and 0.251. 0.125 is the smaller one. So what you're going to do is take these two numbers and divide both by the smallest one. So you're going to divide 0.125 by 0.125. Then you're going to divide the next one by 0.125 again. So when you do that, you get 1 at the top and you get 2 at the bottom. What that means is that for every 1 mole of titanium, you have 2 moles of oxygen. So your final empirical formula is going to be what?
TiO.
TiO2. So your final formula is going to be TiO2. So So write that down, and we're gonna come back and do the next problem just like the way we did with this one.
You made it too hard.
Better be on the test.
Wait, what?
How much one Becca gonna be some extra?
There's gonna be some crazy long problem.
We're gonna have to go from liter.
And then you're going to bring back 6 things.
Never. All right. Yes. No. Maybe. Maybe not. All right. Let's go to the next problem. Okay. Peter, this was a good job reading the problem. Carl, what's up? You just divided it, remember?
0.251 divided by 0.125.
There you go. Okay, Peter, do me a favor, read this next one. Oh, I'm sorry, Asada, go ahead. It's also on your paper.
Oh, that's right.
Louder.
Using the production of nylon aided
Uh-huh.
acid is an organic compound composed of 49.31%.
Go ahead. Percent carbon.
43.79% oxygen, and the rest is hydrogen. Determine the empirical formula of additive.
Okay, good news and a bad news. Good news is that it's exactly the same problem as before. Bad news is that they gave us a percent this time.
Trick question.
Trick question, because it's even easier if they give you a percent.
I know.
If they give you a percent, assume that it's out of 100 grams. And then, if there are 100 grams of this whole thing and 49.31% is carbon, how many grams of carbon do you have?
49.1.
Very good. So, all you have to do is convert that percent sign to grams. And we're going to do that for oxygen too. So, question, exactly, Bria. How can I find the percent or the mass of hydrogen? Right, because the whole thing is out of 100, right? Because it's a percent, and we're going to assume that because it's 100%, it's also 100 grams. We know the mass of carbon and oxygen, so all we have to do is subtract these guys from 100, and I get the mass of hydrogen.
I had that.
It's out of 100%. Absolutely. So this is what it looks like. Lyric, you watching it? If this is overall 100%, right? Let's say 49% is carbon. And 49% is, I know it's like really uneven, sorry. There you go. Carbon. And this percent of oxygen. I'm asking how much percent is hydrogen? It's out of 100. So how do I figure out how big that is? Exactly, and that's what I'm doing. Look at it. I have 100, which is a total. Larry, look at me. 100, which is total, right? I subtracted the part that is carbon, and I subtracted the part that's oxygen. And that gives me the part of hydrogen. You follow me? Okay, so now, have we finished completing part 1 of the process? Because it says to find the mass of each element, right? Now, Naomi, what's my second step? Convert the mass to moles. What are we going to use this time, Nick? What are we going to use to convert the mass to moles? Mass to moles.
You have to use the periodic table.
Mass to moles. Think about it. Mass to moles is the same thing as molar mass, right?
Anybody have any?
That's not 6.02 times 10
No, it's 1 mole.
periodic table. Okay, so let's start with carbon first. What is the unit at the bottom? Grams. The grams need to cancel out. And how about oxygen? What's the unit at the bottom? Good. How about the unit at the bottom for hydrogen? Good. I'm going to give you this time to do this on your own, and I'll come back in 30 seconds to show you the next step. So go ahead and set it up. All right, about a minute and a half. Go get it. Okay, so remember, we're going to assume that it's out of 100 grams. And when you do that, you get 49.31 grams of write them in grams unit. And let's make sure to find my pen. Okay, there it is. So you have this guy. Hello, work. There it is. Okay. And then we're going to say that we're going to convert this to what? Moles. So I have these guys.
We have to do 3 decimal places.
Yeah, that's usually a good thing. Okay, so rule of thumb. When you're getting the mass out of the periodic table to put it underneath the fraction, keep it to 2 digits after decimal. When you divide it out to find the number of moles, keep it to 3 digits after a decimal point. When you get the number out of the periodic table, you keep the 2. Then when you do the math, keep it to 3. Don't worry about 6 right now. Let's just learn what you're doing. Alright, next step. On number 4, what does this say, Akila?
It says if the mole ratios do not turn out to be whole numbers.
No, wait, the one before, sorry.
Find the
Find the mole ratio.
Find the mole-to-mole ratios for each element by dividing the number of moles of each element by the smallest number.
Okay, so essentially what it's saying is, look at all the number of moles you got, and you're going to divide all of them by what?
2.7377.
And why do we have to do that?
Because it's the lowest number.
Because it's the lowest one. So we're going to take this guy, which is the lowest one, and we're going to divide every single one with that lowest one. Now, most common mistake I've seen today is that people don't look at the numbers carefully, and they divide the number that's not with the lowest one. So, but we know better. We're going to divide all of these guys by 2.737, and you get 1.5, 1, and 2.5. Now, these guys are not whole numbers. Now, do not, I'm going to say this again, do not round this up or down. Make sense? Because 1.5 is too big of a gap to jump up or down. What I mean by that is that the only time you can either round down or round up is if you have a number and a 0 and a number, and you can cut off here. Or a number, 0, 0, or a number. Do you get what I'm saying? If there's not a 0 after a decimal point, you cannot round down or up. But Akila did read us what we need to do if there was a number here. So Akila, what is the next step?
If the mole ratios do not turn out to be whole numbers, multiply each ratio by a factor to make each ratio a whole number.
Multiply each ratio by a number to get it to be a whole number. If I multiply these guys by 1, will that give me a whole number? No. How about 2? 2 would work because you always go with the lowest possible factor that can give it a whole number. So we're gonna choose 2 as the magic number, right? So the reason we choose 2 is because when I multiply 1.5 by 2, it gives me a 3. When I multiply 2.5 by 2, what does it give me? 5. Therefore, the molar ratio, in this case, so the empirical formula is going to be C3O2H5. And that is the empirical formula for this problem. Okay, now, you guys write this down?
Why do we choose 2 again?
Because 2 is the only lowest possible factor that can give us multiplication of that. Alright, so let's say
I still don't understand.
you have these numbers. Okay, let me talk, okay? Let's say you have these numbers that end in 0.33, 0.5, and 0.67 in the middle of the test. Okay, I'm just going to save your life right now and say that if you have a number that ends in 6.67, always multiply that by 3. If you have a number that ends in 0.5, multiply that by 2. It will always give a whole number. If you have 0.33, at the end of the number, you're going to always multiply by 3 again. That should give you 0.9999 something. What are you going to do? Round up, right? Good. So fill that in. This is on your notes.
I still don't understand how you got it.
Because that ends in 0.5. You did this math wrong. That's why. All right. Let's go ahead and do the next problem. I want you to do this by yourself. And we're going to come back and look at it together.